go over those four right now because today is the fifth and final method. So let's go over the four we have. 6. Side, side, side. 19. Side angle side. 14. No 14?
14. ASA.
And finally, 28.
Angle side.
All right, there are 4 methods. A few of you thought there was another one yesterday on the quiz. Angle, angle, angle. Angle, angle, side. I mean, side, angle, angle. Or side, side, angle, sorry. Nope, not going to happen. So here's what we're going to do today. I got a 5th and final method. And there is a reason why I saved it for after the quiz and a day all by itself. It is very, very different than the 4 you have been already given. Very different. Even by the letters alone. The 5th and final method is called HL. Okay? The HL method. The H stands for hypotenuse. Hopefully we've heard that term before somewhere in our math career. And the L stands for leg. And this is all on your first page of your notes there. Hypotenuse leg is the 5th and final method. Now, let's talk about this vocabulary term right there, hypotenuse. A hypotenuse is not located in every triangle. I know you say it's a what, the longest side? But it's the longest side in what type of triangle? Right. So what am I trying to push you towards right now? If you're going to use this method, the 2 triangles better be right triangles only. This method can only be used if the triangles are right triangles. Now, does that automatically mean if I see 2 right triangles, that equals HL? No. Here you go. What method is that? That's angle, angle, side. So I don't get brainwashed that when I see 2 right triangles, that equals my new hypotenuse leg method. It does not. So what does HL look like in 2 triangles? What does HL look like? So let me put those 2 right triangles back up on the board. I know, not drawn to scale. Sorry. What did I just mark right there? Congruent sides, which are the what of the right triangles? Hypotenuse, hypotenuses. How do we do this? How do we do this? Spider-Man meme? How do we do this? Hypoteni, hypotenuses. What do we think?
It sounds more scientific.
What's the plural of rhinoceros?
Rhinoceros?
Rhinos. Get with it. All right. I have no idea, actually. Hypotenuses, hypoteni. I'll use both. I have no idea. But those are the hypoteni. And then these would, either of these 2 would be your legs. So here's your H. And then here's your L. Okay? That's HL. Why is it not side, angle, side? I got 2 sides at an angle. Why not side, angle, side? Because angle's not in between. But now we can prove them by the HL method. All right, but right triangles only. All good? And the proofs, an HL proof looks a lot different than the proofs we've been doing. There's a couple extra things we need in there if we decide to use HL. All right, so here's our deal today. We have 3 proofs to do using HL. Very basic, intermediate, beast mode. All right, those are the 3 levels that we have right now. And we will be setting a new record of number of steps used in a proof as well. Because I believe we're at 7 right now. We will break that in a minute. All right, so let's go to our first proof here, basic HL proof. ABC and DCB are right angles, so mark our diagram. AC congruent to DB. And I need everybody to start forming a new habit when we do a proof. And the habit is, do not write down statement 2 unless you have a plan. Okay? And what do I mean by a plan? Keep marking your diagram until you figure out one of the 5 ways those triangles are congruent. Have a plan, because I see way too many times I'll write down all this, all this, all this, and the kid gets to step 6 and they're like, where do I go? I have no idea where I'm going. I'm lost. Have a plan before you write down statement 2. What else can I mark on my diagram that is on me and some of you forgot to do on your quiz yesterday? All right, you have to do this on your own. I will never do it for you. What else can I still mark up here? 13? BC equals itself. Good. BC equals itself.
Hey, what's going on?
Not much. How you doing?
Doing all right. How was last night's Halloween?
It was pretty good.
Good?
Yeah.
Good?
Pretty good. We'll wait for the number to come up. And then I'll ask.
Oh, okay.
Yeah,
All right,
I'll
good,
ask. Yeah.
good.
Okay. Never mind. All right. BC equals itself. Everyone good? Got to do that on your own. Do we see, first of all, is this side angle side? Let me cover this one triangle up. Side angle side?
No.
No, but do you see the H and the L? The H is CA and DB, and the leg is CB. This is HL. Do we see it before we write it? We see hypotenuse leg in action. All right. What else needs to go in my proof? Well, just tell me some things. There is a certain thing that needs to go in there that I need to show you that's new, but you should already know what. There's some things I have on this diagram that are yet to go in my proof. What still needs to be written in my proof? 12. What still needs to be written? What about them? So you want me to say they're congruent? Because that's what you guys have been brainwashed to do. Tell me they're right angles, then tell me they're congruent. You can, and it's not wrong. But in an HL proof only, you do not need to tell me the right angles are congruent. Here's why. When you write the letters H and L, do those represent any angles? You don't need to tell me the right angles are congruent. If you do, it's okay. It's an extra step that's correct. It's okay. All right? If you forget about that. But in an HL proof only, you do not need to tell me the right angles are congruent. You just need to tell me they are right angles. Okay, everybody good? So if you want to keep telling me they're congruent, that's fine. I'm never going to mark you off, but you don't for an HL proof. All right, what still needs to go into our proof? I marked something 17 on my diagram that's not in the statements. 17? What did we just mark there, Riley, that I marked but didn't go in the proof?
CB is congruent.
Yeah, I got to put the leg in there. CB, congruent to itself, a little reflexive. All right, the H and the L have to be in there. I got the H in the givens. Riley just gave me the L right here. So usually we'd be like, all right, 3 steps, triangles are congruent, HL. No. In an HL proof, something extra has to go in. HL is only reserved for what type of triangles? You better tell me you have them then. You better say you have right triangles before you say they're congruent by HL. So the third step before I say being congruent is, hey, triangle ABC and triangle DCB are right triangles. You can only use HL in a right triangle proof, so you better tell me you have right triangles before using it. Now, what would my reason be? Well, how do I know they're right triangles? They have. Right triangles have. Right angles. Great reason. And hopefully, you've said you have right angles, which was given. So that is the extra piece right here that needs to go into an HL proof that's different from the others. Now you can say they're congruent. Triangle ABC, congruent to triangle DCB. For our 5th and final method, hypotenuse leg. Hypotenuse leg. So take a look at it. I just don't want to go right to the next one to get it over with. We have plenty of time today. Anything you want to ask about HL? You have to have right angles. They don't need to be congruent, but you have to have them. And you need to tell me the triangles are right triangles. All good? Anything you want to ask? All right, now we go to the intermediate proof. Whoa, a lot of givens. A lot of givens. Whew. Ready to talk? Because remember, I want to plan. I can't just watch people write down stuff and, oh, where am I going? Where am I going? Look at the proof statement. 1 congruent to 2. Angle 1 congruent to angle 2. So let's go back to, let's see, yesterday was Monday, Friday. Angle 1 and angle 2 are not congruent unless the triangles they belong to are congruent. Right? This is going to be, what did we call this? After the triangles are congruent, what are the angles on all the sides? CPCTC. Good. CPCTC. Which triangles do I need? The ones that contain 1 and 2. Right? I need those congruent. All right, so let's keep planning. Let's keep planning here. I don't want to write. I got a pair of sides congruent. These perpendicular lines tell me these form right angles. And be careful here. Some of you might be having flashbacks of yesterday. BF, is that a side in one of the triangles I need? No. So guess what? I'm not putting an S there. I can't count that as a side because it's not. It's more than a side. You can't count it as a side. Congruent to DE. Now, can we get a side out of those? Yes. But you just can't call it a side right away and do nothing with them. All right? Some of you guys fell in that trap yesterday. Not many, but a few. Do we see where HL's, first of all, I shouldn't even go right to HL, even though it's HL day. Side angle side. Side angle side? Yes, no? No, why not? Is the right angle in between? No. But do you have, what's the hypotenuse in this case? Name the two hypotenuses, hypotenuses, whatever. AB and CD. There's your H. And the L will be coming up when we get BE and FD congruent. How? That's your call. That's on you. But does everyone see HL? Okay, so we've decided HL. Let's rock and roll. Make sure everything we marked gets in our proof. So tell me one thing that's got to go in here way before we say the triangles are congruent. Oh, 14.
EF is congruent.
All right, we are starting the process of getting BE and FD congruent. Good. That's a little reflexive action. That's not a side. I'm not putting an S next to it or an L. All right, we're doing it. Again, you could tell me anything you want. You don't have to go in what's supposed to happen next. You can go in any order you want. Next, 19. Whoa, can we talk a second here about creeping around Mr. Carlino's house during Halloween?
No, I didn't do anything. Riley was the one that rang your doorbell 10
Yeah,
times.
yes. Creeping around Mr. Carlino's house
I was
during Halloween.
like,
Yes.
oh.
Yep.
Oh,
Basically just ditched her friend because you knew it was Mr. Carlino's house and did not want to face me.
No, she rang your doorbell like 10 times, and I was like,
So
why are you
eventually
doing
it was
that?
answered.
Like, if
The
you're
my
not-
girls answered it.
If you're not gonna come to the door, then he probably doesn't want to come to the door. Don't keep ringing the doorbell. So I didn't. I ran
I heard
away.
you just ran in complete direction when you heard it was my house.
Well,
It's okay.
I don't like seeing anybody in public. So.
Okay. All right. Just wondering. I was a little offended, but it's all right. Probably would have been an awkward conversation, but yes. Yep. All right.
BF minus EF.
Yep. Here we go. Equals
DE minus EF.
DE minus EF. Little subtraction. Good. And see, the generator knew I needed to talk about it, so that's why I came up, because you're never called on. Everyone all right so far? All right, I'll take the next step, because we always know substitution comes next. And that substitution is used to say BE congruent to FD. And who comes at 8:40 at night? A little late there, ladies, huh? People are starting to go to bed, huh? Yeah. Yep. That's maybe why I didn't go to the door right away. Yep. But all right, I'll remember that when I correct your next test. Ditching. And there is the leg. All good? Not more, though. I know you had the H and the L, but we're not ready to say they're congruent by HL. I still need what in here? At least 2 more steps. 4, talk to me. Okay, they're right triangles because they have what? Do I have that in my proof yet? So that's the first thing. I need to say I have right angles. It was given to you in the last one. You didn't need to worry about it. But now I need to say angle AEB and angle DFC are right angles. Let's do perpendicular lines, form right angles. Again, if you just, I get it. It's you're brainwashed and inhabit robots. The next step, you might write that they're congruent. Okay, so be it. I don't need it, but it's correct if you ever do that. Now I could say triangle AEB and triangle DFC are right triangles. Right triangles have right angles. Before I go to the next step, let me make a comment. I do not care the order of the letters until you say they're congruent. So I don't care how you name the triangles. I only look at the congruent statement to make sure they're in order. Everywhere else, don't care. Speaking of that congruent statement, triangle AEB is now congruent to triangle. Let's see, if I go AEB on me, I got to go what? CFD. How's that look? In the right order. HL. Why'd we get the triangles congruent? So we could get, congratulations, 8 steps. Angle 1 congruent to angle 2. Let it roll off the tongue. Reason. Anything? Going? You're gonna be like a celebrity now. Everyone wants to know the story.
And then we locked Riley out of the car and drove away, and she chased it.
Anything else?
I was not part of it though.
All right, you ready for the big dog now?
Oh.
See, again, like 0 reaction. There should be an earthquake happening right now, being like, let's go, there's no homework, possible no homework, and nobody knows what we're talking about. A rare double.
Oh, yeah.
Okay.
This is the beast mode proof.
This is why this is a little bit tougher, because I'm asking you to do something you haven't done. And what's that? The proof, right? We usually see that in the givens, but we don't see it in the proof. Whew. All right, so how are we going to accomplish this? How do I do that? Well, let me ask you this. What if I did put it in the givens? Don't mark your diagram, but what if I move this up into the givens? What would you mark on your diagram? I know arc marks. Where? Where would you mark arc marks right now if this was a given instead of a proof statement? Where would your arc marks be? 18, where would they be?
DAB and BAC.
They would be on DAB and BAC. Everyone agrees?
Yeah.
So do it. If you can show me this is true, what's AB have to be? A bisector. So if you can prove to me right now that those two angles are actually congruent, I'll believe you. AB is a bisector, but not until you can do this. All right, let's keep backing up. How's this going to get done? How do I get these two angles congruent? Because you can't say definition of bisector. That's not a given. How do I get them congruent another method? Prove the triangles congruent and then say CPCTC. See our plan? Prove the triangles congruent, prove the angles congruent by CPCTC, and then you can tell me it's a bisector. All right, so let's get the triangles congruent. I know it's HL day, but what else can I mark on my diagram that I have not already? 2.
AB, move to AB.
Yep. And now do we see HL versus side angle side? What is AB acting as? That's the what in HL? That's, whoa, whoa. Oh boy, here we go. We're just yelling out stuff. Hypotenuse, leg, transversal, I think I heard. Yep. Just throw it all out there, right? Why don't we, yep, good. Yep. Why don't we just throw supplementary out there while we're waiting? Factor, anybody? Factor while we're here? Yep. Might as well do that, yep. The AB is the hypotenuse because it's across from the right angles. And DB and BC are the legs. So we still have to put AB congruent to itself. Again, that is your hypotenuse. BD and BC are your legs. So I have HL, but again, that's not good enough. I need a whole lot more before I say they're congruent by HL. What's still got to be said before I write down the letters H and L? 11.
Angle BBA
Yep.
and angle BCA are right angles.
Thank you. Thanks for the
lines form right angles.
Thank you for the dramatic telling of that story. BDA and BCA are right angles. Perpendicular lines form right angles. Again, if all of a sudden your hand just goes in motion and they're congruent, so be it. Doesn't need it, but so be it. I do need to say what still before I say HL? 5. Yep. And again, that I don't care about that order when you write it. Triangle BDA and triangle BCA are right triangles. Right triangles have right angles. Now you're ready. Now we can say in the correct order, name them however you want, right? Name the first one however you want, but the second one's got to match up. BDA congruent to BCA. HL. Why did we want the triangles congruent? So we could say a pair of corresponding angles. DAB congruent to BAC. Let it roll off the tongue, right? CPCTC. And now you're saying to yourself, wait, if those two angles are congruent, then AB has to bisect DAC. Now we got to talk about the reason here, because I know many of you are in the mode of definition of bisects. Nope. Okay. Here's why I don't like definition of bisects. Let me give you this example. Hey, everybody, Emma right here is sitting in a chair. How do I know she's sitting in a chair? And somebody responds to me, definition of a chair. That tells me you know nothing, right? Just by saying definition of a chair, that how do I know she's sitting in a chair? So I don't want, you're saying it's a bisector by definition of bisects. It doesn't not going to fly. How do you know that AB is bisecting DAC based on what we just did? Let me know. I'm not looking for a precise answer here. There's different ways I could go other than definition of bisects. How do I know? What's your deal?
Angle DAB is congruent to angle CAB.
You just proved those two angles congruent, so it has to bisect. That's one thing I like is putting the previous statement. DAB congruent to BAC. Or maybe you actually write it out and say DAB and BAC are congruent, making AB a bisector. All right, I just don't want definition of bisects when you tell me it's bisected. All right? All good? Why are you writing with a pencil? Definition of a pencil. It doesn't tell me anything. Questions? All right, I guess we're done for the day, huh? Live it up, everybody. Live it up.